Start. Okay, so let me start. Okay. This okay. So let me share it. Okay. So today discussion will be on the topic which we call it as a index. Okay. So here, am I audible to all of you? Please everyone mute. Tejo Patel. Yeah. Am I audible to all of you? Yeah.
Yes, sir.
Okay. So let me start then. Okay. So till now, what we have discussed is like what we started with a term called data, then database, then RDBMS. Then we try to understand how ER diagram is benefited for designing the database. Also, we have checked that if I want to design a database, what is the importance of the database design and what kind of rules you can be used for validation like a normalization. Also, we discussed with the first normal form, second normal form, third, fourth, and fifth normal form with examples. And later part, we discussed about three important concepts we started. One is data definition language, where we try to understand how to create a table, alter a table, okay? So all kind of data creations concepts we have discussed. If I want to modify, that is called data manipulation language. That also we discussed, data manipulation language, where insert, delete, update, all these things we have discussed. And later part, we discussed about joins and subqueries and correlated queries. Today, after this topic, I think most of the topic we have covered with respect to a SQL language. But the next important topic we should am I audible to others? Yeah.
Yes, sir, you are audible.
Yeah, someone is messaged as a not audible. Please check your mic. Okay. So now when you talk about the another concept, this is called indexes. What is indexing? What do you mean by indexing? Today we'll discuss what are the different types of indexes, what is the purpose of using that, and then we'll try to understand by creating the index so that it will help to improve the performance of the database retrieval. So that is why people are using the indexes. So basically, when you have a data in the database,
Sir, you are not audible.
no, I am audible to all of you, but to who? Hello, am I audible to others?
Yes, sir, yes, sir.
So I am
Yes, sir,
audible.
you're audible.
Please, Pranjali, you should check your mic or your headset. I am audible to all. Pranjali, it is your issue. Please understand. For all the people, I am audible. Please check your mic. Accept. Okay. Rejoin if required. Okay. Now let me go here. When you talk about database index in the data structure, if I want to improve the speed, because like today 100 records will be there, day after tomorrow maybe 10,000 records, then 1 million records may come. Okay. Like that, if it gradually grows, then to retrieve that, it will be a problem. That means the speed at which if you deliver, then website will be slowed down, right? To improvise that, like especially during the searching kind of mechanism, it is very difficult. So that's why we have to improve that. Okay, what is the advantage to do that? Improve the query performance, enforcement of uniqueness, constraints, sorting, join performance, and filtering. These are some of the key indication for the purpose of indexing. So why do you need indexing? The basic criteria is our select query. When you try to execute on a table, it should take less time. That was the one of the objective of the indexing. And also it should, when we are combining, it should not give the it should give the proper data set, and it should not give the duplicate values. And also index can be enforced the constraints. There are conditions will be there. It may be A table is depend on B, C, D, something like that. In that situation, performance due to the giants may down. Okay. In that situation, we have to understand like how index is going to help to improvise the speed. And also it can be optimize the sorting operations like ordered by, something like that. And also it will be basically when you do the giants, when you combine more than one table, obviously there will be a challenge. And there may be situation like where you are go to a Flipkart or Amazon, when you are searching based on the filtering the data, because it has a huge data. In that situation also, the filtering is most important concept. Okay. So in all these scenarios, we have to improve the performance of our queries so that data can be responded very fast. Okay. That's why in the production system, we are going to, with the help of indexing. So that is called database indexes. So there are different types of indexes we have. In general, we are talking about is one is a clustered index, another one is non-clustered index. What do you mean by clustered index when you talk about clustered index? Okay, if you create a table, automatically primary key is used to create the clustered index. That means whenever if you want to search the record of student, and the index is based on the primary key, and because of that we can able to search. Okay, such type of indexing is called as a clustered index. Actually, it is as good as if you open a textbook, in that chapter headings will be there and page number will be there. So like this, the primary index will be created. That is also called as a clustered index. Okay, what it indicates clustered index? That cluster index will give the physical order of a data in a table, where in which position the data is there. Okay, so that is what you can say that. So that's why whenever you create like a primary key, MySQL automatically creates a cluster index on it. And because of that, performance will be when you are executing using the primary key, it is obviously it will take less time. So that is the objective of the cluster. Let us see that how to create and all those things later part. At this moment, just remember that it is a one type of index. If you look at this example, okay, here cluster ID is there, customer ID is there, page number ID. So assume that, okay, 1 to 10, okay, or something primary key automatically you have generated like a surrogated key. As I said, we already know that what is super key, foreign key, primary key, secondary key, all these things we have already discussed, candidate key. So because of that, we know that at this moment, let us imagine that, okay, there is a customer ID is there, okay, that is the primary key. Based on the primary key, I can tell the the intermediate level I can create the records 1 to like if some records I may be having a pages like a file 1 is having the page 100 4 5 6 up to 6 here. There may be another page is a cluster where the starting from index from X to Y, but each page number I can indicate. Now assume that when you are creating an index, if I have noted down what is the primary key and which is the page number, then it is easy to me that, okay, to search. For example, the customer what you are looking for 10, then automatically it will go for which is the page. And then instead of searching on left subtree, it will go to the right subtree immediately. And it will see that which is the page number 1007. Directly it will go to the 1007 and you are able to see the record of that 10. So primary key is 10, Rahul and phone number you are able to retrieve. So assume that if you have a 10 lakh records, okay, and if you divide like this as a cluster based on the primary key, and it will reduce instead of querying to a 10 lakh records, directly you can reduce that time, okay, which is the, oh, this is the 1000th record. It may be in 1020th page. So then we'll go to the 1020th page of that cluster group. And then that will be having the which customer ID primary key will go and we'll be able to search that particular record. So that's why this is a the one type of indexing, we call it as a, okay, it may be considered as a B-tree index also, but you can say that this is the one type of index. The index means what? In your textbook, how we are going to identify the chapter content or a page content, okay? How are we organized? Similar way it has been organized, and this concept we call it as a indexes. So any questions here? Able to follow? Yeah. Mukta. Yeah. Rihana. So?
No, sir.
Okay. Yeah, no questions. Okay. Then we'll go. Now there is another representation. So I got it here in this link. It was look very nice for me. So if you understand, okay, whenever you think that, okay, maybe like this one root node will be there. It may be representing a number of non-leaf nodes. Okay. And here there may be some record position, physical record position. So this is an example for clustered index article. Same thing, previous one only, representation is given in this form. Now, if I want to search search a record of something like a 81 or something like that, where should I go? I should see that, okay, I cannot go up to 49 here only, this cluster. So above 50 means I have to go to this. In that 80 means either this or this. Like this, you can search. And finally, I can find out 81, 85, something like that. So what are we trying to achieve is here very simple. The indexes are giving the direct access of a record in maximum 2 steps. That's all. So this type of indexes, we call it as a clustered index. There is another type, we call it as a non-clustered index. What is non-clustered index? It does not affect the physical order. Okay, how it was there, it will be there like that only. But here it will, for example, instead of based on primary key, we may use the name, we may use the email ID. So in such cases, these are all called the primary keys, I can say that. And if you use without that, okay, then we call it as a non-clustered index. Okay, non-clustered index. So the non-clustered index, what are we trying to do is, okay, so if you look at the non-clustered index, the similar to that, the physical position of record, we are not touching. Physical position of record. Here at the end, here leaf nodes are the direct records. Here, leaf nodes are not the direct records, but in the leaf nodes, we have updated the position of the record, So that is what we call it as a, after the leaf node, once again, this will be having the pointers to the direct record, and we'll go to this address and we'll fetch that record. So this type of the concept, we call it as a non-primary or non-clustered index. That means while you are retrieving the record, either I can take the clustered approach, another one is non-clustered approach. When you go for non-clustered approach, it will use the other than primary key. When you use the other than primary key, but you have to maintain the physical record, whichever it is there, and that address will be pointed in the third level. So this is how the non-clustered index will be working. That means every time I need a primary key and also address, because primary key will indicate what is the position of the primary key will be indexed here, and we can able to follow that. So that's why the non-clustered index is also one of the way to retrieve the data. So what are the different types? I said finally, clustered index and non-clustered index. In general, we are talking. Physical order, it sorts and stores the data physically in the table order. But here, there is no guarantee of the records physical order because we are just keep updating the indexes. Number allowed, only one per table.
Sir,
Here-
just one
Yeah.
question here for the
Yeah.
physical order.
Yeah.
Sir?
Yeah, tell me.
Yes. So, with the primary key, we are giving the uniqueness to the data, right?
The primary key is uniqueness to the data. From that primary key, we are also telling the which room number where that record is sitting during creation itself in the index based on the primary key. So now assume that I need to access a fifth record. That is a fifth, assume that primary key is 5. And we maintain additional table, but that is called index table, cluster index table. For 5, what is the physical, the position of the table, that where it has resided, that address will be there actually. So because of that, directly I can able to access instead of searching
So,
record.
okay. So in that case, because generally the data will be stored with the primary key,
That will be there.
primary key.
That will
So
be there.
that will change, right? There,
No,
that order will change.
no. See, what I'm talking about is when you are creating, I have not done anything. Created.
Okay. Right,
Then
right.
now, when I create the index, I will show you how to create index. Okay, I create another that. Okay, I will create an index. Okay, when you create an index, automatically, but now MySQL what is telling, by default, it is maintaining another table. In that table, it is not only keeping the primary key, also the address of the position of the record.
Okay.
And because of that, if you know the primary key, directly will go to that record. And in that record, there is another table. I have a details of where that record is located. Okay. And because of that, directly I can access record, right?
Yeah.
So that is what it is doing actually. Whereas non-clustered index means what it is doing is, so it is other than primary key because by default it has created the location details based on the primary key. Now what we are doing, for example, name, that is a email ID, that is a non-primary key if you take it. So the first what it does is non-primary key is nothing but email ID. Associated primary key will be first taken and based on that it will do the searching. That will be maintained. So that is the additional steps it has to do for the non-clustered index actually. Okay. So non-clustered, it has to maintain primary key. Here also it is required. Already primary key knows how to index, it knows that how to select. Here that logic we are keeping. Along with that, we are adding the index also. So index means non-primary key index also. And it may be one column I can take, it may be multiple column. Somehow that is the group of the columns and make it as a non-clustered index actually. Okay. So we'll see that. We'll execute the queries, then you'll understand. So default is primary key. Here manually, other than columns. Storage, data is stored in the index. It's separate index structure with pointers will be stored. When it is searching by primary key, it is going to work. When searched by non-keys, it is going to work. This is the major difference between the clustered and non-clustered index. That means when you are in a company, you have developed an application. If your performance is down, just you have to look towards the indexes and you have to write down the indexes and so that you can solve the problem. So usually when they are developing an index, okay, these are the indexing logic. Sometimes if you go to what we call it as the more popular product companies, okay, they will not leave you asking questions only at the level of clustered and non-clustered index. They may go to the extent where they talk about what is the mechanism probably it has been utilized. Mechanism in the sense, what is the basic data structure array has been used. So one concept we call it as a B tree index. What is B tree index? Balanced tree. Then you have to understand what is balanced tree. Balanced tree is nothing but data structure. So if you do not if you want to very deep, then you should understand, go to the database, try to understand what is B tree, how to construct a tree, then how to construct the balanced tree. Then the same logic it is constructing because what is in general I am at this moment, what is balanced tree? It is it means that, let me see here. So for every like a level, the same number of children are there. Like that, we maintain the balance. So that is what called balanced tree. As a layman, I am talking about here. So one is very lengthy and one is the like a half length. It is not like that. For example, if one record may be third level, third or fifth level, another record may be only on second level. So like that, it will not be there. So it will be just one level. So that is what we are talking about, the balanced tree. All the leaves, all the root nodes, when you reach, it may be all searching index will be in third level or second level you are going to achieve. So that means everything is balanced. You do not require to deep dive to the any subtree actually. So that is what we are talking about, the B tree index. When you're constructing, when you're inserting, deleting, updating, so it will follow the balanced tree logic. So it should be a balanced structure. Always data stored in sorted order. That will be easy for us when you create a primary key. If data is sorted order based on the primary key, and it would be very easy to find the corresponding position. And also like a supports for all kind of queries, okay, and used for primary, unique, and composite index, and used for all kind of keys actually. So this is what we call it as a B tree. In other words, for a clustered index, by default, it is using the B tree mechanism only. Internally, it is a B tree structure only it is using actually. There is another concept, we call it as a hashing. Usually, if someone comes from Java, they can able to understand actually. This is the most popular diagram. So if you browse it, you can see many places here. Okay. So what we do is it is based on the hashing function. If someone knows how hash map will be done, if someone from the Java background, so hash map or hash table construction, the similar structure will be there. What is hashing? When you apply a function on some logic, some algorithm, automatically it should give the address of the record. So this is another technique we can use for indexing. It may be clustered or non-clustered, but this is a logic we are talking about. It is the logic we are talking about. So that means indexes is main objective is performance. So like improvisation. Here, what we are talking about is hash function or B tree index. These are all the mechanism can be taken by clustered or non-clustered index. So this is what algorithm we are exploring. So here hash function, you are applying the hash function. It will be going for some buckets. You do not require to worry too much. Okay, just assume that it is some buckets. Bucket means some pointers to the address. So when you run the hashing function means it can be any algorithm. Okay, block box. So whenever you compute some hashing on this record, okay, assume that record 1, okay, it should give the physical address like 153. Some algorithm you have done, like where ID plus John Smith plus some address together. When you compute an algorithm, it has given address location is 153. It maybe belongs to a one bucket. From 153, when you get into a bucket has a physical address location of this actually. That is a memory location of that record. So it may be physical location of that record. So likewise, the hashing technique will be working. What is hashing technique? Hashing means when you apply, it will give some address. Here we are talking about the hash function, which is giving the address of bucket. Bucket has address of the record. So this is also a way to organize the record. And if you want to do internally, they may use the hash index also. Another important concept we are talking about is like a bitmap index. So what is bitmap index for a large data? If you have a large data set, so sometimes there will be some records. If you use always a character, so then it is very difficult to, because of that performance may be degraded. So that's why they started thinking instead of using a B tree or a hashing function, probably they might have used another technique we call it as a bitmap index. What it is bitmap? Let us see here. Then you will be able to appreciate what is bitmap. So here, assume that this is a table you have created. In that gender is there, income level is also there. Okay. Now, Like we decided instead of B tree in cluster index, it is planned to use the bitmap index. Now, if you look at that gender, okay, so bitmap means what? It is in binary representation bit. So if you look at that, if it is a male, M, how do you represent male? M1, okay. Then second record 0, third record 0 because both are females. So that means 1, 0, 0. And fourth record is 1. So because it is a male, so I have added. Then F is 0. So that means we got this objective bitmap for a gender. Gender, I can say that instead of M, I can represent in this bitmap value, binary value. Similarly, if you go to the female, it is a reverse process, right? Here, first one is 0, next 1, 1, 0, 1. So this is how it has been done. Okay, so you done now your bitmap index is nothing but it has this also, it has this also. If you look at the income level also, if I want to represent, represent. So assume that like a L1 means 1, 0, 1, 0, 0. So it has done 1, 0, 1, 0, 0. So this is done. Similarly, L2 means L2 only one time it is repeated. So 0, 1, 0, 0, 0. So that means 0, 1, 000. So that is a L2. Similarly, if I want L3, okay, L3. So it has only one unique 0, 0, 0, 0, 4 zeros, then 1. Similarly, if I want to go for L4, so L4 is the 3 zeros, 1, then 0. L5, all the records, there is no, this one, it has shown the 0, 0, 0, 0. Now, this type of indexing, we call it as a bitmap indexing. Usually, like a, if I want to perform and or not operation, okay. So then sometimes people may, instead of using B tree, they can use the like a bitmap index as well. So best to low coordinate columns like gender, status, department, such data, if you want to consider, then it is the best approach. Good for read heavy workloads, data warehouse and OLAP systems, efficient for complex and RF filtering. Okay. Not suitable for high coordinate columns like email, phone number, lengthy details. Okay. Not ideal for frequent updates like insert or deletes. So this is why we call it as the bitmap index. Similarly, we have another index type is full text index. So any questions here? Bitmap index? Bitmap index, any idea? Any questions? Able to follow, right? Yes, sir. No. Bharti, Mukta.
Yes, sir. Yes, sir.
Okay. So now we have understood. Now what we have understood, don't get, because this most of the time, these topics, they are not covered in the sessions, okay? But practically when you go for the project, obviously you have to create an index in case performance challenges. So in that space, you should understand internally, understand that, then you do, it would be easy for you. Now, when to use bitmap index? So when you have simple male, female, only two, like a status, maybe on, off, or something like that. Department, only 3 department. Such type of things only you should use, otherwise it will become very lengthy. So bitmap like a index will be used instead of lengthy procedure. So that was their expectation. Okay. But it is not identical. If you are every time you are updating, every time you are inserting, every time deleting, this is not the ideal approach. That is what they are telling. And another important concept is full text index in MySQL. Nowadays, all data science people are doing that. Okay. Like in SQL, earlier days only it was there, but now from last 2 to 3 years, people are having the buzzword of data science, data engineering. Okay. But earlier also, railway reservation system is the biggest system we had in India. Now also it is there. But only thing is, now we are talking in the technical buzzword, and with the simple word, we are creating the lot of the concepts around it, and we are using it is just like a specialization. So earlier, the common doctor used to give the treatment for all kind of diseases, but now we want to separate it out. Okay, that is a specialization. Similar to that, same pattern has been applied here also. So now instead of B index or something, there may be sometimes you will be using the text-based information. Okay. And if the remarks, comments, okay, people are putting that. How do you retrieve such data? So that is what the full text index in MySQL. It is used for optimized text search, supports for natural language search like a match against. These are the methods we have. Better than like, and also works with varchar and textual characters. So basically, we have a textual information, and if I want to retrieve some information based on that some queries, then full text index is going to help us. So let me go quickly and show the few execution so that you can able to visualize that. Okay, visualization is most important for us. So let me go here. Now we have understood what is index. We have understood what is clustered and non-clustered index. We have understood, and within that, what are the algorithms they are implementing, like a B tree. So all these things we have discussed. Okay, hashing we have discussed. Okay, bitmap we have discussed, and full text index we have discussed. Now let us see that if I want to create, and we can, if you want to feel that, okay, how to create that. So let me go here. So here for the sample code, you don't find the difference because like a majority of time, we know that what we are doing only simple records will be. But when you are in the cloud, okay, huge data will be there. So that's why in such situation, this will be helpful actually. So let me go here. Okay, so I have created. Let me close everything. Drop it. Now I think most of the people are comfortable using this. Okay, I believe that. Okay, I have done this. Now this is a SQL editor. So as usual, so we used to do this. Now instead of typing, I will take a how to create a cluster index. So just I'm taking a one table. So just follow me. Now you will be able to understand. Create table employees, primary key, name, and department. Primary key, since it is available in this table, and always by default in MySQL, it will create an index actually. So now let me execute this. Before that, I have to create the database. Create database, UPLDB. Create. So similarly use UPLDB. Now let me execute this. So it has executed. It has selected. So we can see that it is selected, UPLDB. Now let me create it. So how do you create? Create employees, name, ID, department. So it has created, I think. So employees is created. Now if I want to insert, these are all the things we have learned. So we are going to insert the records. Insert into employee ID, name, department. So let me execute this. It is working fine. Let me add this. So now let me refresh it. So we have columns also, and we are able to do that. Now let me execute and check. Okay, so once this is done, if I execute, so you can see that. So like all the records are inserted. Now, once this is done, I wanted to create index. So how do you create an index? So this is what required for. So create index and name of the index. Name of the index based on the department primary key, it can create an index, and all employees department. So it is creating an index, name is index department, employees, and creating a department. So now if I, this is how the index has been created. So we can see the index. If I want to see that, then you have to go here. So then show index. So you can see that there is a index called index department. So based on the primary key, it has been done like this column name department. And this is how the base type is called B tree. So this has been used. So this is how we can understand how simple clustered index is working fine. So any questions here? Able to understand how are we creating? Assume that you have developed the application, you created the design, and you have inserted the record, but performance slowed down. Then quickly you go and create here on employees, and then automatically it will start working. So any questions here? So can I continue?
No, sir.
Okay. So next, similarly, if I want to have a more than one column, okay, as an index, okay, not only primary key, I need, if I want to come up with some unique pattern, so then we can that also we can do that. So first, let me create the university. Let me go and create a let me create this. First, we can create a university, then use the university, then create a students table. So now we have created a student table. So then insert data. Now querying data using the composite index. So if you want to get that, assume that select star from employee where department is equal to not equal to computer science and year is equal to 2020. Like this, like you can execute some results, but underlying it is using the indexing concept. So it is able to search. Similarly, find the students from department, order by year and marks. So that is also one more concept. Let me go here. So let me. Okay, so this is how this has been created. Highest marks in each department for particular year. So this is all. It is a normal queries only. You can notice that we have not done any modification. But only thing is, okay, so see, you can see that, okay, whatever you are expected, it will be there. If the highest marks in the each department for a particular year, so you got it. So based on the department, we are getting the, what is the highest score from the topper. So this is how we can do that. If I want to verify it, there is an explain term you have to use. And index, you can see that index department year marks. So index department, this one. This is how we can create a index. So any questions here for creation of index? So Mukta, Bharati. Yeah, just you have
Shall
to.
we just shall we just execute that explain command?
Yes, yes. Okay. That is like each the vendor will give in different way. Like if you so it is executing. So it is telling that simple index on table now. It is explaining the information, giving the information about the index. Okay.
Okay.
So here you can follow this. If this lab set, when I send it, you just see that. Similarly, bitmap index already set. Okay. So how do you create? Here also similar to that one. So create a student. Just quickly, I will do it. Okay. Let me drop it. Or let me close this. So we're in the university. Okay. Let me drop this. I will recreate it. Now let me create a student. So the clustered index is created. Insert the sample. So we have done this student. Now create a bitmap index table. So that means you have to create a bitmap. This one, like we have seen, like how gender index and all. So same thing, the bitmap index. So you can create that, the bitmap index table. So gender, auto increment, tiny int unsigned. So like this, you can create it. It will create it. Now after that, if you execute, you can execute.
So, sir, what is that? Is that the syntax?
Which one?
Um,
So
Gender
you,
bitmap, tiny int,
yeah, so usually,
unassigned.
yeah, see, let me explain you, okay? Bitmap I have shown, right? This one. So earlier, how we used to do that? It is creating one table and we have done. This is one more technique, bitmap. In MySQL, it is not handling as it is. In PostgreSQL and Oracle, it will follow certain syntax. And whereas here also we can achieve through the bitwise operator. So what is bitwise operator? I already explained. In a table, there are specific records. Instead of using characters to search or creating a non-cluster approach, they are using the integer to perform and or not, so that the performance or objective is to reduce the time. For that, what they have done, the gender, if I wanted to say that, like a what the, in binary format, if I want to represent. So I can say that like by looking at this, so I told that 1 0 0 1 0 0 1 1 0 1. Similar to that, if I want to perform in MySQL, okay, and represent, and if I wanted to use that, so first we created the student table and bitmap table for any one short-term representation, that is gender we have used, and then we have done the bitmap operations. But for that, first what I created one table, then I created a insert records, then bitmap index table where like a gender bitmap we have created, but here physically we are creating, but there may be some functions exist in the other vendors, but here we are following the bitmap. This bitmap procedure we are following, and we are executing. Like we take 1001, MBA 010, like that it will be created and stored actually.
So, sir, there will be another table created for just storing the index values, is it?
Yes. That is what I told actually.
Okay.
Additional
In the
memory will be.
other index, it's not like that, right? It's on that table itself.
No. For everything, there will be taking the other table. But here, other index, the clustered or not clustered index, the additional memory will be consumed. Memory wise, it increases, but performance wise, it reduces. It is as good as you have a textbook. In textbook, when you read chapter 1, chapter 2, that's okay. But if I want to map that, what will you do? First page, you will write the index chapter index, right? Like that, they will be maintaining separate tables.
Okay. What is this unassigned, sir?
Where is that?
Tiny int
No, these are all
unassigned.
positive 001. The negative value is not there. Okay, because they have taken tiny int means small bits. Okay, instead of 8-bit, 4-bit is to be used. Why to use unnecessary number of digits to consume the space? So at that time we will be using like this. So
Yeah, tiny int is data type. What is unassigned?
unassigned means that's what +1 -1 signed. Sign means what?
Oh,
Plus or
okay.
minus. Negative value or positive value? How do you represent? Okay, for indexes, what is the
Yeah, got it, sir. Thank you.
negative index? There is no meaning, right? Yeah. So likewise, just I am showing you people when we are learning SQL, we are usually will not get into this level. If you are team lead or architect, we'll go to this level. But for me, like if you have this level awareness only, you can become exactly a good developer. So that is why we are getting into that level. That's it. And it is not a rocket science also. Just you should have a awareness. That's it. So bitmap means you have understood some calculation if you do see finally what is our objective? Improve the performance. What are the possible ways to do that? The one technique we are using the indexes, and there are the different possible techniques we are exploring. That's it. So if you store in that way, so here when you do join, instead of text comparison, something like that bitwise and Okay, we can apply, and this will be this. If it is a 10 lakh records, if you apply like this, the number of seconds, the time it is used, it will be reduced. So that is why people are using the bitmap index for certain the column values. We can use the bitmap also. That is why fast filtering time we can use it. Space also you cannot use more, so we can save that. And any combinations we can use it using AND or something like that. So that's why people are using the bitmap index. Just for the timing, I have shown you how to represent in binary format, and that binary format we are going to use to map a certain column so that the operations can be executed efficiently instead of writing a plain query. So that is what we are trying to do that. Similarly, another type we talk about unique. Unique index also is the distinct index you can create. So how to create? They can use the unique. If you create a table unique, then add a table unique, you can create it actually. So this is how, like when you create this one, apply the unique constraint, it will create the unique index. So unique column. Earlier by default primary key, based on that, it cluster index will be created. Assume that primary key itself is not there in your table, but unique column will be there, right? On that based also you can create the index. So this is how it is going to do that. That's why the unique index has been shown here. How automatically when instead of creating by default MySQL creates based on the primary key, but assume that primary key itself is not there in the table, then you can take the help of unique some unique column. By applying that instead of primary key, we can do that. So that is what this example was created. So this example was created. So if you want to create an index, you can create index. Unique email means automatically the index will be created on this. Now,
So just here,
yeah,
one question, sir, here. For this unique index, when we will have so is there anything like where we when it comes to the question like where we will be applying this unique index?
no, unique means, see, for example, in your table, see, this is the one table, students table. Okay, for example, instead of primary key, I am querying based on only on email majority of time. Okay, so instead of that, okay, take the reference of primary key and follow that. If you make unique, this is by default, it is creating a index based on the another memory location based on the email. The location details will be maintained and it will be helpful for the fast search. So what is our objective? For example, if you go to a Flipkart, not always you are not searching based on the primary key, right? You are searching based on other columns also. So in such cases, the one example is there. If there is a unique column, we can easily search. And if you create unique like this, okay, automatically it's creating an index. And using that, then when you execute the query, automatically you can able to retrieve the record faster than normal query. So you got it?
Okay.
Okay. And if you want to drop, you can drop index. So you can explicitly also you can tell that. Similarly, we have last part we were discussed as full text index. What is full text index? Like sometimes we have like a text information, content to blogs. Okay, the lot of text information is there. If I want to search, machine learning algorithm we are talking about nowadays. But earlier days, how we used to do that? There is a certain guidelines are there how to search based on the content, SQL content. For example, if you look at here. Assume that I have an article, title and content, and these are the title and these are the values. So like this it is there. Now I wanted to load only like articles which are having the SQL term. So something like this, SQL term. So now there is a concept that the SQL has given the one query called match, title, content. So against to the full text, if I try to do that, then so match is the one, it is improving that, okay, improving the searching criteria. So that like now percent like match. So these type of things is trying to improvise the performance. So how it is improvising? It is because of the indexes created internally. So that's why if that was the case, on which I have to create index, you have to mention full text. full text on which title content. So then index will be created on title and content. So then it is easy to search based on the title. If I search, it will be the performance will be more. Not only primary key, you are also taking the additional non-key. On top of that, you are telling that full text, this is a textual content. And there may be a possibility that I may compare with some part of the word and to retrieve the search. So in that situation, instead of seeing 10 lakh, 20 lakh records, I may maintain the another index table where I can map from title and content to retrieve the records. In such cases, the query performance will be improved. And because of that, within 30 seconds, I can load the or search that content. So that's why we used to use the indexes. This is one more option we have when we have a textual information. So what it is going to do, but only thing is you have to use these functions like a perform a full text search, then use the match function where match title or content against a full text. If you do that, you can able to do that. Like this, you can follow. And the more majority of time now NLP like that natural language related kind of things we used to do this. So what is we try to explain today is we are telling that okay, there is a concept called indexes. If you're facing some performance issues, just remember there is a concept called indexes. And there are different types of classification are there in that like a clustered and non-clustered index are there. In the clustered index, or non-clustered index, what are the mechanism they have applied? So we can say B tree, hashing technique, bitmap, full text, unique. So these are the different techniques are there. Using that, if you are able to create, then automatically the query performance you can improve. But only over it is additional memory will be consumed. So this is the objective of today's session. So is it clear? All of you got a clarity? At least. Okay. So basically people in the interviews, we know SQL joins and all. Suddenly if they ask about indexes and all those things, we could not able to answer. That's why this session we wanted to give for those people if they are struggling to, there may be a situation that you may join for the company. They ask you to improve your performance because earlier it was working fine. Only 1 lakh records are there. Suddenly they said that performance slowed down, improve the performance. Then where do you look into it? And you have to look into if whether it is a database side, I have to fine tune, code side, I have to fine tune, or front end side, I have to fine tune. You have to decide. And if it is a database side, always the performance will improve a lot. And then you should have the awareness of these things. Practically, we also face this type of situation. Someone has when we deployed the application, someone has forgotten to execute the index queries. And we are facing suddenly next day a lot of queries from across the people saying that the data is loading. But after one day, we realized that there may be a chance that we forget to execute the indexes. So please understand the importance of indexes in terms of performances. In case if you are able to do that, I think the query level, if you are able to optimize, definitely. But only problem here, memory, too much memory will be consumed. So that is the only worry. But anyhow, nowadays hardware, no one cares. Only they care about the performance. So with this note, today's session will conclude. Thank you very much.
So
Yeah.
just one question. Though this is like there are map data is also there, right? Nowadays people do come with that non-tabular data. So
textual, non-text
not
data.
textual.
Textual info that we will discuss. That is SQL kind, non-SQL. No, not only SQL. No SQL.
No SQL data.
Yeah.
So we'll discuss that.
Yeah.
So my just one question, so that it will be just pointer for when we will be going ahead. So just when we will have tabular or non-SQL data, in those cases also this indexing is possible?
No, they internally now already, big data, like all these people are Hadoop, they are talking about, right? This is the evolution based on the indexes only. So we are talking here, it is the basic foundation only we are talking in the SQL concept.
Not in terms of Hadoop or this, I would say. I would say that in terms of semantic web, like semantic data kind of things.
No, see, most of the time, like indexes has been used, but internally it has been computed. So now, for example, now Flipkart, they wanted to, the remarks you will give. So remarks means the text comment. Now I wanted to do the sentimental analysis on that text. Okay. And you wanted to get some substring, search, occurrence, algorithms. Those are all the things will be part of NLP, natural language processing. How all those things are they are going to work actually efficiently. There are this type of sort of algorithm they might have implemented. And using that algorithms, we are going to improvise the performance. Okay. But at this moment, what are we trying? So now database is there not only today, before the data analytics, data engineering, DBA, everything was there. But earlier days, DBA people used to control through this type of queries by writing queries and improving the performances. That's why I have given the example for Indian Railway system. Indian Railway system is the biggest system. It was there and written on C programming, and they are able to map the performance so effectively, right? But now also the same process is there. Okay. But only thing is that time it is a very hard to the common people to address that actually. If people should have a memory, a lot of knowledge is required. But nowadays, what is that? Everything is conceptualized, and anyone like me or you can learn those technologies and we can implement it in our applications. So we are simplifying, but basic data structure, concepts, everything remains same at the end of the day, but everything is people are abstracting data. That's it. Okay. So thank you very much for all of you joining. Thanks a lot. And we'll resume my session from Monday. Thank you.
Thank you, sir.
Thank you, sir.